Hello, good morning, guys. Myself Muhammad Thajuddeen. So today it's a explanation about the topic vision. In this section, we will investigate about the sense of the vision. Vision, it's our most important sense. Certainly, a complete loss of vision would have a most profound effect on the lifestyle of the average person. The study of vision does not normally fall within the limit of medical biophysics. All large hospitals have ophthalmologic doctors, scientists also. So, in this chapter, we can ask about the question what do we see, how can we measure it, how can we see it, and how good is our sight, and how can go see a sense of vision goes wrong, and what remedies are available. So, what is a light? The light is, according to the Newton, the light is the smallest tiny massless particles. But Huygens states that light is the most wave-like structure. It have a wave-like motion. So the major problem that could be stand the vibration on a mechanical medium was available to vibrate. It is also known as light propagated through a space, and therefore unlike the medium was available, there is no medium available in the space. Maxwell derived the mathematical theories of electromagnetic waves and demonstrated that light exhibit the properties expected electromagnetic radiation. Old idea dies hard. After a long time it was postulated that whole of the space was pre-emitted by ether that was capable transmitting the vibration of the light without having any mechanical effect on the bodies such as planets traveling through it. It is only when the scientists proved unable to detect ether that was it finally accepted that it could be a non-mechanical underpinning of theories of electromagnetic waves. So we have that wavelengths of the different electromagnetic radiation, like we have a visible light like violet, blue, green, yellow, red, orange. They have 400 to 700 nanometers of wavelength. But in the other radiation like UV gammas, the gammas have 10 to the power minus 14 meters, and X-rays approximately about 10 to the power minus 10, and like that we have electromagnetic radiations waves. So we have used electromagnetic radiation over the whole spectrum in the various application of the medicals, and many have covered in this chapter of this book. Visible light occupies only narrow band from the 400 to 700 nanometer. For a comparison, the wavelength of the sound in the audible range is 20 Hz to 20 kHz. In air is 17 meter to 17 millimeter. So what is the speed of light? The speed of light travels in a vacuum approximately is 3 into 10 to the power 8 meter per second, or 186,000 miles per second. So it is in the air. What about in the other medium? So we can write that n, it is a index of refraction is speed of light in the vacuum divided by speed of light in the medium. So we can get that in the index of refraction is in air is 1.0003, and in water is 1.3, and glass is 1.5. So in the case when the light passes through a different medium, it will cause refraction or reflection. When the light from one medium into another medium, it travels to one medium into another medium, the frequency cannot change, but its velocity must be changed, or it will be changed. The wavelength changes to accommodate the change in the velocity. At the fixed frequency, wavelength is proposed to a speed, therefore ratio of the wavelength in a vacuum to the wavelength in a media, it is called the index of refraction. So when the light passes through a medium, there is a small refraction which is called angle. There is a change in the angle which is determined by Snell's law. So now what is Snell's law states that? Snell's law states that n1 sin theta 1 is equal to n2 sin theta 2, and n1 is the index of refraction of first media, and n2 is the index of refraction of second media, and the theta 1 is the angle of incidence, and theta 2 is the angle of refraction. So by can we get, and we have the lens which is used to maintain the focal length, so we can calculate the focal length also by 1 by f is equal to n2 minus n1 divided by n1 into 1 by RA minus 1 by RB. So RA is a radius of curvature of the surface of the lens, and RB is the second surface. So when the light passes, there will be an interference of the light waves. Light waves interact or interference with each other in the same way as does the sound waves do. The relative phase of the waves determined whether the interference is constructive, which is increasing in intensity, or destructive, which is decreasing or reducing in the intensity. Both interference can be observed experimentally by looking the pattern produced by two phase locked point sources separated by known distance illustrated in the point. The point sources are A and B. They are separated by the distance small letter separated by a distance small letter s. The seen place is placed parallel to the other end of the s distance s, capital letter S, and we can get that delta is equal to BC minus AC, which is approximately Hs by S, where Hs by S is equal to n into lambda. This experiment gives the measure the wavelength of the light, examining the space between the regions of constructive and destructive interference. The problem of ensuring and sources phase are overcome as used in the source. So what is a diffraction? In the diffraction, it is a preceding section we have looked in the how light waves slits or interfere. So we can do a slit experiment. What is slit experiment? By this, there is a small source and which interfere, which forms the different diffractal pattern, which gives the answer is theta is equal to sine inversely sine to the power minus 1 into wavelength divided by omega, and omega is equal to width of the slit. This is all about the nature of the light. So how can we see? We can see by the eye. So we can study about the human eye's anatomy and physiology. Human eye is approximately spherical in shape, and main features with respect to the sense of visions are cornea, iris, lens, and retina. The first three are focusing and filtering devices that present the sharp image in the retina. Cornea, iris, and lens are filter and focus the light, and a retina to get the sharp image. In common, the components of outer to the middle ears, their function might be regarded are essentially mechanical. In such description can be applied to the process involving that the transduction of light energy into electric energy are function of the photoreceptors in the retina. So the anatomical structures are outermost layer is in front of eye is cornea and surrounded by the sclera. And inside there is a pupil, which is a small opening which can light is passed through it, and there is a iris, which is a muscle which is used to change the focal length of the lens, and there is a retina, and there is a blind spot, and there is a two humors inside posteriorly vitreous humor and anteriorly aqueous humor. So the only interruption of these tunics of posterior portion where the optical nerve shafts ending have. So the innermost layer is retina, which itself consists of two layers, and outer single layer and inner pigmented layer, and an inner neural layer contains photoreceptors. The former reduce reflections and more detail in the latter. So the two chambers of eye, as I said, anterior and posterior, are filled with the fluid. The anterior segment is filled with aqueous humor, like a clear plasma like fluid continually drained to replenished, and there is a pressure about 16 mm Hg. And the posterior segment is filled with the vitreous humor or clear viscous gel that not replenished. So the lens in the component that does not have final focusing of the incident light into the retina. It is a biconchave but is not symmetrically so. In the general shape is a particular curvature of the surfaces. So I said there is a photoreceptors in the retina. There are two types of photoreceptor like rods and cones. The rods are distributed over the whole of the retina, and with the exception of the immediate area of the entrance of the optic nerve, there is about 125 million rods in the retina. On average, something like 1 lakh millimeter square of its surface. The density of the highest annulus is 30 degree of the fovea, which is a gradual reduction along this location. There is no rods in the fovea, but they have low intensity threshold. Our night vision is almost entirely attributed to the rods. The light sensitive pigment within the rods is called rhodopsin or visual purple. The wavelength or absorption spectrum of the rhodopsin matches almost exactly the wavelength or the spectrum of the human eye. The peak sensitive rods is light to the wavelength about the 510 nanometer, which is the blue or green range. So the action potential occurs very rapidly. At the early point of the cycle, there is a minimum supply of rhodopsin in the rods, as this adaptation of eye in the night takes place up to 30 minutes. Why the eye in this condition called scotopic or dark adapter? An essential element of the rhodopsin cycle is availability of the vitamin A, and deficiency of vitamin A which will cause nyctalopia or night blindness. So there are about 7 million cones and the highest cone density in the fovea centralis. So the intensity of sound is defined as a term of energy flux power per unit area, and it is Weber meters per meter square. In the pure physics text, propagates a light like sound are often described on the system of the behavior of the point source. The properties of electromagnetic radiation depend on its wavelength. For example, we can only see the radiation in the wavelength spectrum about 400 to 700 nanometer if we understand the predict the effects also in the spectral distribution. So, the radiation of electromagnetic energy from the surface of the black body governed by the Planck's radiation law, which is expressed as m lambda, which is equal to 2 pi h c square divided by lambda to the power 5 into exponential to the hc divided by kt lambda whole minus 1, where m is the existence of wavelength lambda over the interval of d lambda, and h is a Planck's constant, which is 6.63 into 10 to the power minus 34 joules, and k is the Boltzmann constant, which is a 1.38 into 10 to the power minus 23 joules, and c is the speed of light, which is 3 into 10 to the power 8 meter per second square, and t is the temperature of the body. So that's all about the vision and photo of the eye. Thank you.